All right, quick video today. This is for section 6.5, and what we're talking about, excuse me, is the triangle mid-segment theorem. Couple of things that you are going to absolutely want in your notes is this diagram, and a couple of things that you know about that diagram. So the way the triangle mid-segment works is I've got this triangle, ABC, all right? Now, if I find the midpoints of the triangle, so if I find the midpoints of each side, and this one is already labeled D, this midpoint is labeled E, and there's some midpoint down here that I don't know because it's not labeled, right? But we would call that F. Now, if I connect D and E, if I connect these two midpoints, a couple of things happen. First of all, this line that I just created is parallel to AC. They're going to be parallel with each other. That's what that little symbol means that I drew, is that they are parallel. What also happens is that line DE is exactly 1/2 of the bigger line AC. All right, so the mid-segment line that I made by connecting the midpoints is half the size of the regular line. So if I know that AC is equal to 12, then that means DE is going to be equal to 6, all right? If I were to connect F and E right here, I know that's not the best midpoint I've ever found, but if I knew that AB was 28, well, FD or FE, this line that I drew, connects the midpoints that are parallel with that AB. So that means that FE would be half that length. It would be 14. All right. And then the last one, if I were to connect F and D, if I were to connect those midpoints, and let's say FD is equal to 7, then I would know that BC is twice that big. It's 14. All right, so the regular side of the triangle is twice as long as the midpoint line, the line connecting those midpoints. So let's use that a little bit. Here's a problem. Triangles are used for strength in roof trusses. In the diagram, UV and VW, so this line and this line, are mid-segments of the triangle RST. All right, so I've got this big triangle on the outside, RST, and then I've got these midpoints, U and V and W, and they're connected with these mid-segments are what those lines are called. It wants me to find UV, so it wants me to find this length right here, and it wants me to find RS. It wants me to find this big line right here. Okay, so UV, let's start with that one. UV is parallel to RT, and it's connected by the midpoints. So that means that UV is going to be half as long as RT. And I know RT. RT is 90, so that means UV is half of 90, which is just 45. So UV is 45 inches long. Now RS is the long side of, it's the outside of the triangle, right? Well, I know that VW, this mid-segment, is 57 inches. So RS is going to be twice that long. So RS is going to be 2 times 57, which is 114 inches. All right, so not too bad. Most of the time, you're just doubling or cutting numbers in half on this one. I do like this question a lot. Pear Street intersects Cherry Street and Peach Street at their midpoints. Okay, so this is a midpoint right here, and this is a midpoint, which means this Pear Street is what you call the mid-segment, right? Okay, you leave your home and jog down Cherry Street. Well, I guess, oh, your home is at P. So there's your house right there, okay? So you leave your home. God, blue's kind of hard to see. Let's give red a try. You jog down Cherry Street to Plum Street. So you go all the way down to Plum, over Plum Street to Peach Street, and then you go up Peach Street to Pear Street, over Pear Street to Cherry, and then back home up Cherry. Okay, so you ran this little path right here. How many miles did you jog? All right, so a couple things that I need to keep in mind. All right, first of all, this road right here is a mid-segment. So this length is equal to this length because it cuts it in half, right? So this entire length I can cut in half. And I like to start filling out what I know. If that entire length is 2.25, then this piece is 1.125, and this piece is 1.125, because I just cut 2.25 in half. I also know that this is the midpoint of Cherry Street. So this piece and this piece are the same. So if that one's 1.3, then this one's 1.3. What else do we know? We know this is a mid-segment, and it's parallel to Plum. So that means this street is half of Plum. So if Plum is 1.4, then this one is 0.7, because I just cut that in half. I think I have enough now to add everything together. So I start by running from P all the way down to this corner, which is this number and this number combined together. So 1.3 plus 1.3. Then you run across Plum Street, which is 1.4, so plus 1.4. Then you run up Peach Street and stop right here at Pear. So you didn't run all the way up, you only ran halfway up, so I need to add 1.125. And then you run across Pear Street, which is 0.7. And then you run up this half of Cherry Street, which is just the 1.3. So if you add all of that together, this becomes what? 1, 2, 3, that's 4. That's 2. And if I add this piece, that is 7.125-ish, about, miles. Cool, easy, easy. A mid-segment triangle has lengths of 3, 4, and 5. All right, so a mid-segment triangle, if I have a triangle drawn right here, a mid-segment triangle is the triangle that is formed by connecting the mid-segments, all right? So if this triangle has lengths of 3 and 4 and 5, then the real triangle, since those are all mid-segments, this one would be 10, this one would be 6, and this one would be 8. Done with that one. All right, last example. This one isn't out of the book. This is my example. So I want you to draw this quick picture, ABC triangle, and then draw the mid-segment triangle within it and call it FED. So pause real quick, draw that triangle if you need to. Okay, so here's what I want to give you. We're going to say that FE, that the distance of FE, so let's write this mathematically correct. The segment FE is equal to 6x plus 16. Okay? BC, let's make that segment 4x plus 48. And the question I'm going to ask you is, how long is BC? How long is the segment from BC? I know what it is, it's that function, but I want to know what is that length equal to. So I know a couple things. I know that FE is the mid-segment for BC. So that means it's half as long as BC. So I can make an equation out of that. I can say that BC, let's write it this way, is twice as long as FE, right? Whatever FE is, 2 of those is equal to BC. So let's write BC, 4x plus 48. I want to take what I know, and I want to make it into an equation. is twice as long as 6x plus 16. And from here, I can just figure out what x is. So 4x plus 48 is equal to 12x plus 32. Now I got to do some railroad track stuff. I'm going to minus 4x over. So I get 48 equals 8x plus 32. Then I'm going to minus 32 from both sides. So I get 16 equals 8x. Divide by 8. X is equal to 2, which is great information. It's not my answer, but if I know that x is equal to 2, I can plug that into these equations to figure out how long they are. So let's plug it into, it wants BC, so let's plug it into BC. So 4 times 2 plus 48. That's 8 plus 48, which equals 56. And if BC, if this is 56, then that means FE should be half of that, which is 28. All right, homework questions. What I want you to do, let's see, homework numbers. Let's do, I marked some of them. Let's do 7 through 10. That'll take you like 30 seconds, probably not. 17 through 19 are worth your time. Those look like the example that we just did. Let's see. You know what? Let's do 21 as well. And I want you to do, you know what? 21's probably enough. Let's just add 21. So 7 through 10, 17 through 19, and number 21. Make sure you can do those problems and you'll be ready for this section of the test.